So part two of the digestive system, we stopped at the esophagus. And the esophagus, let me say this first. For the secretions, here is one thing that goes without saying. The whole entire digestive tract, all of it, you secrete mucus secretion. That's it. Okay? Period. It goes without saying. If I ask about anything, esophagus, yes, mucus and whatever. Stomach, mucus and something else. Intestine, small intestine, large intestine, anything. All of them secrete the same thing, plus or minus. And now esophagus, there is nothing much. Just the food, when you swallow, it enters to the pharynx, it moves down, go to the esophagus, and the peristalsis will move it down until it go to the stomach. And I mentioned we have two types or two sphincters for the esophagus. There is the upper esophageal sphincter and the lower esophageal sphincter. And lower esophageal have another name. What's the name? Cardiac sphincter, because the next piece or the first part of the stomach is the cardia, and that's why the name where the name came from. The other thing is this cardiac sphincter, to be strong enough, it is a sphincter anyway, but to be strong enough, it passed through something called the hiatus. It's an opening in the esophagus, and there are muscles in a diaphragm. It passed through the diaphragm. There are muscles in the diaphragm that strengthen this muscle. This lower esophageal sphincter is not strong enough. So if you contract your stomach, food can go up. How to prevent that? You have muscles, extra muscles in your diaphragm, and these muscles strengthen the lower esophageal sphincter. So that will bring us to the hiatal hernia. Did we hear about this before? Like food goes up and you have this heartburn all the time. They tell you it might be hiatal hernia. What is this? Because if this opening in the diaphragm is wide, the muscles are not strengthened. The sphincter and the sphincter alone is not enough. It's not strong enough. So muscles, same thing. We have mucosa, submucosa, muscularis, and serosa or adventitia. And so esophagus, it's not different than anything else. All of them have the same thing, but it's very important to remember one thing that's unique. All of them have the same thing. What's unique? Like in the stomach, we said there is oblique layer. This is unique, right? Here there is something unique. What is it? Stratified squamous epithelium, non-keratinized stratified squamous epithelium. Is that different than after anything after the esophagus? Of course, yes. It's different because starting from the stomach, the mucosa there or the type of epithelium is simple columnar epithelium. And I told you the difference. Stratified squamous epithelium is resistant to mechanical trauma, while the columnar is resistant to chemical. That's why this is good for the esophagus. This is good for the stomach. There is no acid, much acid in the stomach. I mean, in the esophagus, so it's good. It's physical or mechanical. But the stomach, this is all the acid. It is in your stomach. Here are all these layers: mucosa, submucosa, muscularis, and adventitia. The process of swallowing is also known as deglutition, and obviously you need to know both, just as usual. Deglutition is the same as swallowing. Swallowing is, if you wanted to swallow, it's not that simple. Remember, what's the name of the foods when you're done digesting it, mechanical digestion in your mouth, and then you swallow? What do you swallow? Bolus. Yes, it's an oval-shaped food that's already mechanically digested, not 100%, but to a good extent, mechanically or physically digested, and then you swallow. What do I swallow? Bolus of food. Okay? How do I swallow it? It's not that simple because when you swallow, your tongue, the base of the tongue, push backwards. Number two, the larynx moves up. When it moves up, it gets closed by the epiglottis, right? At the same time, the uvula on top close. So now the food is moving in, the base of the tongue push it backwards. It cannot go up to the nose because of the uvula, and it cannot go down anteriorly to the respiratory tract because of the epiglottis. You end up having one way only going to the esophagus. And we call that swallowing. All of this coordinate together. Who is coordinating this? Swallowing center in the medulla oblongata. If you forgot any center that is regulating anything in your abdomen, it is in the medulla oblongata, just like this. If you forgot it, it should be not just there. Anything in the trunk, actually. Any coordination, any center, they are all in the medulla oblongata. So swallowing center is what's coordinating all of those. And it's located in the medulla oblongata. So the food in your mouth, this is called the buccal. And then it moves backward to the pharynx. And we call that pharyngeal part. And when you actually swallow, we call it esophageal part. So look at this. This yellow is called the bullous. Look at the tongue pushing backward. Look at the soft palate and the uvula, specifically uvula. This soft palate and uvula, it close the entrance or the exit to the nose. And look here, this this is not the trachea. The trachea is here. This is not accurate, but that's okay. This is the larynx, and when the larynx moves up, this epiglottis close the entrance, and that's why you're not supposed to talk while you're eating, because if you wanted to talk, you have to open the epiglottis, and the food or drink will enter into the larynx. So buccal phase, push it backwards, everything is closed, goes where? Goes to the pharynx. Which part of the pharynx? Oral, which is behind the oral cavity. The next is pharyngeal phase. It go to the oropharynx and start to move down laryngopharynx. In order to do that, you have to close the epiglottis. After the laryngopharynx, it moves to the esophagus, and then the peristalsis will keep pushing it down until it gets to the intestine right here. So we have to pass this lower esophageal sphincter. Look at this. What is this? What am I pointing at? This and this. This is the sphincter inside here. What's this outside? What is this opening? H, start with H, the opening. This is the diaphragm. Hiatus. And this opening is a hiatal opening, esophageal opening. If this is wide, contents from the stomach can go up. It's called hiatal hernia. Stomach is the next part. And stomach, it does the following. Number one, temporary storage. Temporary storage. Number two, mechanical digestion. Number three, chemical digestion. Right? So it's just like the mouth. Remember the mouth? We did mechanical and chemical, right? Which part is the chemical part? Saliva and tongue. What do you have in the saliva and what do you have from the tongue? What are the enzymes? Hmm? Close, very close. Salivary amylase. And the other one, lingual. You have to remember these. Lingual what? Lipase. Lingual lipase. These are the two secretions. So in the stomach, what else is extra? Just temporary storage. And what entered the stomach? It's the bolus of food. Does it leave as bolus? No. In the stomach, you will go in the stomach, you do the mechanical digestion, you do the chemical digestion. At the end, what's leaving the stomach, and you have to remember, is called chyme. And this is one of the things that will enter into your mixing bowel, which is the duodenum. Okay, so it's what's happening in there. We will talk about it. In the stomach, there is lesser curvature, the small curve. And on the other side, this is the greater curvature. And the parts are cardia, which is the very beginning. Then this up there is called the fundus, and then body, and then pylorus. Pylorus is antrum and canal. Together, we call it the pylorus. So antrum is the beginning, and I told you guys before, antrum means a funnel-shaped entrance to something, antrum, and then canal. So antrum followed by canal, what do we call both of them together? Pylorus. At the end of the pylorus, there is a pyloric sphincter. What's the function of any sphincter in the body? Any sphincter, any valve, same function. One way movement, right? One way movement. That's it. From part to part. This is exactly how it looks like. Look at this. Lesser curvature. And this is the greater curvature. This part here of the pylorus, this funnel-shaped part right here, this is the antrum. And then this part here is the canal. At the end, you have the sphincter. Muscles, you have 3 layers, not 2. There is longitudinal outside, there is circular inside, and this is anything else is the same thing. What else do we have? Inside both of them, oblique. And why do we have an extra layer? Because you still need more mixing and more mechanical digestion in the stomach, which is not the case in anywhere else. The inside mucosa of the stomach is called rogae or rogae. Okay, this rogae is like folding uh, uh, in order to allow for the stomach to expand. That's why you have these folds. And these folds are going to disappear when the stomach is full. So remember this, rogae. What's a rogae? These are the folds in the stomach to allow the stomach to dilate, to expand. When it's filled with food, you don't see these folds anymore because the stomach is dilating, expanding. It disappears. Once you empty the stomach, it come back. There are different secretions that come from the stomach, but the lining of the stomach, I mentioned it several times, simple columnar. Again, esophagus is stratified squamous. Mouth, all the way until the end of the esophagus, stratified squamous epithelium. Anything after that, simple columnar. There are glands in the stomach that secrete a lot of secretions. Stomach is a little bit more complicated than anything else. So there are different secretions. And in this part, you need to be specific when you tell me which cells secretes what. Okay? You have to remember this. So we have parietal cells and sheath cells. Beside the gastric glands, there are glands that secrete mucus secretion. This is something else. I'm not talking about those. This is everywhere. Plus this, beside these glands, what else do we have? We have parietal cells and sheath cells. Both of them together, they make the gastric juice. But which is which? This is something important to know, and I will tell you. If you get a cut section of the stomach, this is what you're going to see, the wall of the stomach. Just like anything else, mucosa, submucosa, muscularis, and serosa. Which one is inner? Circular or longitudinal? Circular. What's inner means? Closer to the serosa or closer to the mucosa? Closer to the mucosa. Very good. So you will see these folds and the opening of the folds. There are glands in these folds, and the opening here is called the gastric pit. The gastric pit. So the mucus secretions come out of this. So here are the gastric glands. There are different types of glands. There are G cells, sheath cells, and parietal cells. Each one of those 3 secretes something that you have to know. And you have to be specific here. G, parietal, and sheath. Each one of those secretes something. Generally speaking, there is mucus secretion anyway from the gastric cells. But there are other secretions that come from different types. Parietal cells. Parietal cells, what do you secrete? You secrete from the parietal cells intrinsic factor and hydrochloric acid. Intrinsic factor and hydrochloric acid. You have to be specific here and you have to remember this. Intrinsic factor and hydrochloric acid come from the parietal cells. What's intrinsic factor? It's a factor. We talked about that in the blood. If you forgot, intrinsic factor is secreted from the parietal cells of the stomach. This is needed to be able to absorb vitamin B12. You don't have it, you don't absorb vitamin B12. So if somebody's having like a surgery or something and they cut piece of the stomach and these cells are gone, vitamin B12 deficiency right away. No matter how much you eat, yes, no matter how much you eat, you cannot enter it. It cannot go in. You cannot absorb. You have to have the intrinsic factor. Okay, so some people can have vitamin B12 deficiency anemia and they are eating tons of vitamin B12. It doesn't matter because deficiency is not, you're not eating it, you're not absorbing it. So remember this intrinsic factor. How about the chief cells? Chief cells secrete something called pepsinogen. What do you say or what do you remember when you see gen at the end of any word? Generate something. Is that active or inactive? Inactive. How to activate? Remove what? Remove the gen. So pepsinogen, is that active or inactive? Inactive. We secreted inactive. When it's activated, remove the gen. Make sense? So what do you call it? And instead of pepsinogen, pepsin. It's called pepsin. Pepsin is actually active. Why? If I see a question like this, why do you secrete it inactive? Just secrete it active and save yourself a step. No, we secrete it inactive so that it does not digest our own stomach if it's empty. Okay? It's activated when the food is in your stomach. This is when you actually need it. And why do you need hydrochloric acid in your stomach? Two functions, two things. Number one, I need it to kill the pathogens. It's very strong. It's an acid, killing the pathogens. Number two, it helped breaking down the proteins. So it helped the process of digesting the proteins. And that's why we have this. Number three, hydrochloric acid is what activates pepsinogen to pepsin. Did we get this point? Three things. Hydrochloric acid, killing the pathogen, starting the process of or helping the process of digesting proteins. And number three, this is the one that actually activates pepsinogen to pepsin. Why is it done like this? Everything is happening for a reason in our body, and this is physiology. It's all understanding. Why is it secreted and active? Because if our stomach is empty, you don't want to digest your, isn't your stomach inside our cells and they contain proteins? You can digest it. So you don't want that to happen. So to solve this problem, I secreted in active. When do we need it active? When the food is in your stomach. When the food is in your stomach, you secrete hydrochloric acid, right? Hydrochloric acid activate pepsinogen to pepsin. There is a way to get this hydrochloric acid somehow, and you secrete also alkali, but details are not the most important thing to know. How can we get the chlorides and we get the hydrogen and put it together? That's all right. Enzymes that are secreted from the stomach of the newborn infant specifically. There is gastric lipase, and this one is not only in the infants, it's everybody. You have it, gastric lipase. The extra one is renin or chymosin. This is something that helps babies to digest the mother's or the breast milk specifically. So for adults, what do we have? I told you so far, chief cells secrete what? Intrinsic factor plus pepsinogen, which will become pepsin. Okay? Parietal cells secrete and hydrochloric acid. Okay, so you got three so far. And then gastric lipase. This is an enzyme, not a hormone. How about the G cells? Did you see the G cells in the picture? Remember parietal and chief. There was some cells called G cells. G is the first letter of gastrin. Gastrin is a hormone that is important. Very important. Without it, this is like the ignition of the stomach, gastrin. Gastrin, when the food go to the stomach, or actually even before that, gastrin is secreted. And this is the one that stimulates those two cells. It stimulates parietal cells, it stimulates chief cells. Are we following? Gastrin is secreted first. This is like the ignition. This is the start of the stomach. Once you secrete gastrin, it will go to those two types of cells, parietal and chief, both of them. Okay? Parietal cells secrete intrinsic factor plus HCl. Chief cells secrete pepsinogen. Now I have those. HCl will go to the pepsinogen activated, but the whole chain start from gastrin, from the G cells, gastrin. There are also another type of cells that's called D cells. D cells secrete something called somatostatin. Somato means huh? Stomach. Somato is stomach. Okay? Statin is coming from static. So somatostatin, static to the stomach. It means it inhibits the stomach. You know, static and dynamic. Dynamic is to move. Static is to stop. So somatostatin, it stop the stomach. So that inhibits the stomach by inhibiting gastrin. Why do you want to inhibit gastrin? If you're overworking, if you're secreting too much, if there is a lot of HCl, why do you need all of that? Or how about this? After you do all of that, what leaves the stomach? What do you call it? What's the paste that's leaving the stomach? Chyme. So when the chyme leaves the stomach, do you still need all these things? The stomach is empty. Why do you need any of those? I don't. These cells secrete somatostatin. Somatostatin stop gastrin. Gastrin do not stimulate parietal and chief cells. Everything stops after the food leaves the stomach. Does everything make sense so far? Okay. So we mentioned in a mouth, we have lingual lipase and salivary amylase, right? Salivary amylase, what does it work on? Carbohydrates. Amylase, amyl is sugar. Amylase, carbohydrate. What else? Lipase work on fat. Rule of the thumb. ASE. At the end of any word, it's an enzyme that breaks down something. What is that something? The beginning of the word. Lipase, an enzyme that digests lipids. Protease, enzyme that break down proteins. Amylase, enzyme that break down amyl, which is carbohydrates, and so on. It's everything. Put ASE at the end. This is an enzyme. So we have lipase and amylase. So where did we start the process of digesting carbohydrates and lipids? In your mouth, just a little bit. And then in the stomach, same too, but they're called gastric because they are coming from the stomach, but same too. So in the stomach, you have gastric lipase uh, that's secreted from there, and pepsin that's secreting, digesting the proteins. The stomach is very acidic. It can be like 2. What's neutral? 7. So 2 is very acidic, isn't it? It's close to 0. Do we absorb in the stomach? We say no, but it's just a little bit, so we just ignore it. Okay, it's not absorption. The stomach is storage, mechanical digestion, chemical digestion. Chemical digestion is the big part. All what I talked about so far. Okay, so what do we digest in the stomach? Lipase, just like the mouth, and you have pepsin that digests proteins. So far, carbohydrates, fats, and proteins, all three start to be digested. There is a lot of control on the gastric activities, just like anything else. Every time we say the same thing, right? What's the control of anything? Nervous system, endocrine system, and local. Do we remember this? It's everything. Nervous system, endocrine system, and local. Nervous system. I think we know what's the nervous system do in the stomach. Nervous sympathetic. What does it do? Stimulate the activities or inhibit the activities? Inhibit the activities. Inhibit the activities. If you are in the middle of the fight, is the stomach a priority? Digestion is a priority? Absorption is the priority? No, it is not. So you inhibit the activities. What do you mean by activities? Both secretions and motility, both of them. Parasympathetic is the opposite. How about the hormones? We talked about gastrin that's secreted from the stomach. And there is also the short reflexes, which is just moving the food from one piece to another piece that's going to do a reflex and produce the secretions. And actually, the gastric phase is three phases, and it goes like this: cephalic, gastric, and intestinal. This is the phases of the gastric control. How we control our stomach. Three phases. Number one, what happened when you see food or you smell? Something happened, right? You get some secretions in your stomach. You feel different, right? When you smell food, when you see the food, it's different, right? Actually, when you see the food or when you smell the food or you are about to eat, your brain is going to send the signal to your stomach, get ready, food is coming. And we call that cephalic phase. Cephalic is brain, right? So the brain sends the signal, but there is nothing in my stomach. Yes, it's just preparing. Okay, you start secreting the gastrin, and the gastrin start to go to the parietal cells, get ready, chief cells, get ready, food is coming right now. Okay, so this is cephalic phase. When you think about it, when you see it, when you smell it, cephalic phase. When you actually eat, this will be the next part, which is called the gastric phase, which is what happened when the food is actually in the stomach. Okay, and what happened when the food is in the stomach? Gastrin is released, stimulating the two cells, right? And the rest. We have mucus cells, chief cells, parietal cells, G cells, and D cells. You have to remember all these cells. Mucus cells, parietal cells, chief cells, G cells, D cells, five cells. Five cells in the stomach that you have to remember. So what happened in the gastric phase? Food go to the stomach after you swallow, stimulating gastrin. Gastrin stimulate parietal and chief cells. You secrete hydrochloric acid and pepsinogen. Hydrochloric acid activate pepsinogen to pepsin. So now you're ready to digest your foods. Local. How about the local reflex? Yes, when the food is in the stomach wall start to expand, stretch, and this will make more secretions. pH. When the pH goes up, because of the food, this is also going to stimulate because gastrin, when it comes, HCl will be secreted and pH is going to be dropping down. The last phase is the intestinal phase, which is the food is leaving now and going to the mixing bowel, which is the duodenum. Then what? What's going to happen here? The duodenum is going to secrete certain things. What are these things? Well, the food is already, what do you call the food leaving the stomach? Chyme. So the chyme is leaving now. Do you still need all these secretions in your stomach? Your stomach is empty, right? The chyme is leaving already. It's in the intestine. Do you still need the stomach? You need all these secretions in an empty stomach? Of course not. So what should I do now? Inhibit the stomach. Okay? Plus other secretions. So what are we going to do here in the duodenum? We're going to secrete GIP, gastrin inhibiting peptide. Does it make sense that you inhibit gastrin? The food is already left and the stomach is empty. Why do I still need gastrin? I will release gastrin inhibiting enzyme or gastro inhibiting peptide. And I'm also going to secrete secretin and CCK. And each one of those have a function that you need to know. Okay, the digestive system is a little bit complicated. It's not, I wouldn't say very hard, but it's a little bit complicated because of all of these secretions that you have to know. Okay, so CCK and secretin, what is this? CCK. What's CCK? Cholecystokinin. What's cholecyst? Cholecyst is the gallbladder in Greek. Cholecyst, gallbladder. Cyst is bladder. Chole is coming from bile. Cholecyst. What's kinin? Kinetic, right? What's kinetic? Movement, isn't it? Kinetic means movement. So what is this? CCK, cholecystokinin. What does it mean? Movement to a gallbladder. What does it mean? What do we do in the gallbladder? We store what? Bile. So what's the CCK is going to go to do? It's going to go to the um, gallbladder to contract and push out its bile. And the bile will go to the duodenum. Remember when I told you there are the question that I answered for you, mixing bowel, what goes to the stomach? Well, what goes to the duodenum? I'm sorry. The chyme, this is one, and the presence of chyme will release these hormones. CCK will contract the gallbladder to secrete, release its bile. Remember, we do not, we do not make the bile in the gallbladder. Gallbladder is just a bladder. It's just a storage. We make it actually in the liver. We make the bile in the liver. We store it in the gallbladder. So since you store it there, why do you store it in the gallbladder? Because I need it only when the food is in the duodenum. You're not going to waste your bile, right? Do you want your bile to go from the liver all the time for no reason? No. I would rather store it in the gallbladder, and only when the food is actually in the duodenum, I send a message to the gallbladder, give me the bile now. So the gallbladder contracts, pushing the bile that go through the system until it reaches the duodenum, and this is the second source of the mixing bowel. Paste, the chyme is number one. Number two, this is the bile. And what's the bile for? What's the bile function of the bile? Breaking down fat. It's called specifically emulsification. Emulsification. You have to remember this word. Emulsification of fat. It emulsify the fat. You know what emulsify means? It's what? Yes, you separate it, you break it down. It's exactly when you clean your dishes. If you clean your dishes, specifically if you're eating something that has fat, isn't it hard to wash it? Like if it contains a lot of fat and then you put it under the water tap, it doesn't clean it, right? You have to add something. You have to add this dishwashers or right? You have to add this liquid. And what does it do? Emulsification of fat. This is emulsification. And this is actually how did they make it? Like the first person who discovered this, like you're trying to clean the dishes, it's not cleaning. So he think about it. Do we have bile in our body? And this bile emulsify the fat, so to break it down into pieces. How about we take this idea and make something that does the same job? Yes, this is how exactly how they did it. So it is emulsification as well. So what when you clean the dishes, you're emulsifying the fat. It's the same idea. Okay. So this is for bile. How about the secretine? And actually, the other function of cholecystokinin. What's the first function of cholecystokinin? Contract what? Gallbladder to release bile. The other function is after going to the gallbladder, it go to the pancreas until the pancreas secrete enzymes. And this is the old name. When I was in the medical school, we used to call it like a huge name like this. It used to call it cholecystokinin pancreozymin. This was like the largest word in medical school. Cholecystokinin pancreozymin. It's like 25 letters. But to me, it make more sense. Cholecystokinin pancreozymin. Cholecystokinin because it contracts the gallbladder. Pancreozymin, enzymes of the pancreas. And this is the other function. Now they just say CCK, that's okay, but it's still the function didn't change. It also tell the pancreas, secrete your enzymes. So what's coming now? Bile is coming, CCK. enzymes coming from the pancreas, CCK still. How about the secretin? Secretin tell the pancreas also secrete bicarb, not the enzymes. So now, if you put it together and if you see that question, I'm telling you how to answer it. Here it is, everything. The food coming, which is chyme, bile is coming for the fat, pancreas, enzymes, and that's it? No, not just enzymes, bicarb. Who tell the pancreas to secrete the bicarb? Secretin, another hormone, secretin. And why do you need the bicarb to be secreted from the pancreas? Because remember, what's coming from the stomach, which is the chyme, don't you think it's very acidic? It's full of acid, isn't it? It's coming like loaded with acid. And the duodenum and the intestine is not as strong as the stomach. Stomach is like the strongest mucosa for chemical resistance in the body. So isn't the duodenum is also chemical resistance, yet not as good as the stomach. So what should I do now? I should have bicarb. Isn't the bicarb neutralize the acidity? Do we still remember this? The bicarb neutralize the acidity. Yes, this is what we have to do. So if I ask you what all the secretions that come from the stomach, it's not only chyme, it's chyme and bile and enzymes and bicarb, all of these. So here is the pancreas. The pancreas is head, body, tail, head, body, tail. And there is a duct inside of the pancreas. And this duct is what's going to deliver what I just mentioned. What does the duct deliver to the duodenum? Two things. Pancreatic duct. What are the two things? What is it? No, what are the two things that come from the pancreas? Enzymes and huh? Bicarb, yes, bicarb. Both of those. They will come through the pancreatic duct and go to the duodenum. So what's the function of the pancreas? The pancreas have two parts that are different, and we will focus on one of them, not both. The one that we already talked about in the endocrine system, do you remember the islet cells? Alpha and beta that secrete insulin and glucagon. That was the endocrine system. These cells are in an island in the pancreas, and this is the endocrine function. And we're not going to focus much on this. This is endocrine. We will focus much on the pancreatic acids, which secrete the pancreatic juice. What's the pancreatic juice? Water, enzymes, bicarb. Water, enzymes, bicarb. This comes from the regular pancreatic acini or the regular glands. Look at this picture. Head, the head in this C-shaped duodenum, neck, body, and the tail is here. And here is the pancreatic duct. This is the main one. Look at this. The main one goes down like this. But there's an accessory that goes up. Where is the main open at? What is this? Major duodenal papilla. And this? Minor duodenal papilla. So what's coming in this duct system here? It's the pancreatic juice or the hormones? Juice. The hormones are separate. And the hormones doesn't use duct anyway. Okay? So what's the endocrine function? Glucagon and insulin. And we talked about this, the endocrine function. The exocrine is our focus, which is called the pancreatic juice. What do you want us to know about the pancreatic juice? Water, enzymes, bicarb. Water, enzymes, bicarb. Water, nothing, it's just water. Bicarb, bicarb, just neutralize the acidity. How about the enzymes? All types of enzymes, period. Everything come from the pancreas. Like before that, I was telling you two things in the mouth and two things in the stomach, right? Pancreas, everything. What are the organic molecules that we know? Carbohydrates, proteins, lipids, nucleic acids. Do you secrete enzymes for all of those? Yes, all of them, everything. for carbohydrates and fats and proteins and nucleic acid. Everything come from the pancreas. So do you secrete amylase? Yes. For what? Carbohydrates. How about lipase? Lipids. How about nuclease? Nucleic acid. Proteolytic enzyme. Proteins. So it's everything? Yes, everything. Here is the amylase for carbohydrates. Here is the lipase for lipid. Nuclease, nucleic acid. Proteolytic enzymes for proteins. And this is protease is one and peptidase is one. What's the difference? Do you remember the structure of the protein? Protein is amino acid, amino acid, amino acid, peptide bond. What do you call it together? Peptide chain. And when you fold it and make it the whole thing structure, you call it protein, isn't it? So what should I do with the protein? You break down the protein into, not amino acids yet, into peptides. And then peptidase to break down the peptide into amino acids. And this is your goal. Your goal for everything is to break down the foods into the smallest pieces. What are the names of these um, proteolytic enzymes? Same as we mentioned in the stomach, it's not secreted active. It's secreted inactive. And then you're going to activate it. So trypsinogen, what's the active for trypsinogen? Trypsin, just remove the gen. How about chemotrypsin? Chemotrypsinogen, chemotrypsin, okay? And there are others like pro-carboxypeptidase and pro-elastase, that's okay. Trypsinogen is the most important one, okay? Trypsinogen and chemotrypsinogen. So this will become trypsin and chemotrypsin. What's the trypsin? Do you remember the pepsin? Pepsin, pepsinogen, pepsin, trypsinogen, trypsin. That's it. It's the same idea. Pepsinogen become pepsin to digest what? Proteins. Trypsinogen become trypsin to digest proteins. Same thing. Same as chemotrypsinogen. Liver is the next one, and this organ is the manager of the whole metabolic activities in the body. It's the manager of the digestive system. And as you remember, in the lab, we said there's right lobe, left lobe. And what's separating those two lobes? What's the ligament? Falciform ligament. They will ask you about it. Falciform ligament. Anterior. This is in between the two lobes, attaching it to anterior abdominal wall and the diaphragm, both of them. It goes like this, anterior abdominal wall and diaphragm, falciform ligament. It's different when you look in the back because you will see two other lobes, quadrate lobe and caudate lobe. And I told you that to know it, if you see it in your exam, quadrate is coming from quadrum, square. You will see it having four borders, quadrum, right? What's caudate? Tail. You will see like doing like this and has a tail. This is how to know them from each other. So there are another two that you can see in the back. The falciform ligament, part of it is called the round ligament. If you look at it at the bottom, there is round ligament coming out of it. Porta hepatis is that door of the liver, and I told you about it before. And there are things that enter and things that leave, and I mentioned it, right? Porta hepatis. What's the porta hepatis? It bring what? Blood containing absorbed nutrients from the digestive system. So does it go into the liver or leave? Enter. It takes the blood with nutrients into the liver. It enter. Okay. What else enter? Hepatic artery. Hepatic artery. Okay. And what leaves? The biliary system in general, the bile ducts. And what's the bile ducts? It's leaving, isn't it? Leaving with what? Bile. So where do you make the bile? Liver. You make it in liver, and that's why it's leaving, right? The cells of the liver are going to take care, I should say, just take care of the nutrients in different ways. So when the nutrients that you absorbed in the intestine, it travel in the blood, in the porta hepatis, enter to the liver through the porta hepatis, and goes in, branching, until everything go to the liver cells. The liver cells are going to take care of it. Here are the lobes, right lobe, left lobe. This is a falciform ligament. And look what's here at the bottom. It's called a round ligament. Round ligament, it used to be one of the blood vessels of the fetal circulation. Do you remember all these vessels in the fetus that's obliterated and change into ligaments? Do you remember these? So this is one of them. It's a round ligament. It was connected to the placenta. So if you look from the back, you will see this is quadrate. Look at this. It doesn't look like a perfect square, but can you identify four borders? One, two, three, four. Can you identify four borders here? No. Do you see this tail? You cannot identify the four borders. You see the tail. Quadrate, caudate, and this is the porta hepatis, hepatic portal vein entering, hepatic artery proper entering, and the bile duct leaving. So it starts from here, and we will talk about this system. So there are a lot of lobes inside the liver, and inside these lobes there are different cells. There is the hepatic vein. When it enters, it's going to branch, branch, branch inside until it will make something called central vein. Sinusoids are located in the liver, and these sinusoids will go into the central vein, and the central vein is going to branch out. There are cells in the liver that are called satellite cells or Kupffer cells. These cells will phagocyte. We talked about this, I believe, in the blood, the Kupffer cells. Do you remember when we talked about the macrophages and microphages and then the specialized eater cells? Remember this, the dust cells? This is one of them, Kupffer cells. So look at this. This is a shape. This is a lobe, a shape that have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. It's a hexagonal structure in the middle. This is not important for the lab, just to understand how it is arranged. There is always a central vein in between each four of those. And in this part right here, you will see the vein, the artery, and the ducts. We call it the portal triad. This is a portal triad: vein, artery, and biliary system. Hepatic portal system, I mentioned that already. And this will go into a triad, which contain vein, artery, and duct. And the biliary system now. Where do we make the bile? Liver cells, hepatocytes, right? When it leave, it go into a tree. Do you remember the bronchial tree? Like the opposite of the bronchial tree. It will go the opposite. So you start with the tiny, very tiny, like leave the cells and go to the canaliculi. What's the difference between canal and canaliculus? Smaller. Eculus. When you add eculus, it's smaller. Do you remember in the eye? Canaliculi. It's the same thing. Eculus at the end means tiny. Canaliculus, the tiny canals. So we start with canaliculi, collecting the bile, come together to make hepatic duct, right and left. And then together it will make the common hepatic duct. The common hepatic duct is going to join the cystic duct that's going to the gallbladder. I will show you the picture to make more sense. So here is a bile duct or the cystic duct and common hepatic duct together. We call it the bile duct or the common bile duct. And this is the one that will go all the way to release the bile into what? Go, not the gallbladder. The common bile duct release or bring the bile into duodenum, the mixing bowel, the duodenum. Look at this system here. Inside the liver, canaliculi. Now look at these two. This can be in your exam. Pay attention. Look at this. Right and left hepatic ducts. They join together to make common hepatic duct. And then cystic duct. Cystic is coming from the cyst. What's a cyst? Gallbladder is called cyst. Bladder is cyst, just another name. Bladder, cyst, same thing. So joining together make the bile ducts, also known as common bile ducts. Look at the common bile duct. It's behind. It will go to what? What is this? Major duodenal papilla. What else go to the major duodenal papilla? Main pancreatic duct. So if I ask you a question, what the major duodenal papilla is bringing to the duodenum, can you tell? Common bile duct bringing what? Bile. And then the pancreatic duct bringing enzymes and bicarb. So all of these together will come from this major pancreatic or major duodenal papilla? Yes, major duodenal papilla. I'm answering questions as we go. So here it is. They come together. And before opening into the major duodenal papilla, they go into something here that's called the duodenal ampulla. And the ampulla is the one that will open there. So they come together, you join together. Yes, there is no separate opening for each one of those. They come together, they merge. And there is actually a sphincter that's guarding the common bile duct and another sphincter that's guarding the pancreatic duct. And then they come together into the duodenal ampulla, this green, and then open here major duodenal papilla. This is how it looks like. If we do a radiograph, they inject something and they take a picture. This is how it looks like. And here is the whole thing. Canaliculi, right and left, hepatic ducts, common hepatic duct, cystic duct, common bile ducts, and it goes into the duodenum. So what's the function of the liver? One of them we already mentioned, making bile. We talked about this, right? Second function is it's the manager of the digestive system. It manage all nutrients. Give the nutrients to the liver, and the liver will tell you what to do. Bring it to the manager, and the manager will tell you, let me see what you got. Did you get carbohydrates and fats and proteins, all of this? Okay, we will need part of it. We will convert part of it and store it, and so on. We will add, we call that together metabolic function. Bile production, metabolic function, and then part related to the blood that we already talked about. What's the hematological part? Do you remember what happened when the red blood cells are aged? After 120 days, it go to liver and spleen, and we break it down. Remember this uh, bilirubin remnants. Do you remember this? We break down the red blood cells, and which contain hemoglobin. You take the proteins or amino acids back. You take the iron back, and you call the remnants. What do you call the remnants? Bilirubin. Okay, bilirubin will go with the bile. What else do we have? The liver also remove toxins. Detoxification. The liver remove toxins. Do we have toxins in the food? Of course. You never know what did you eat exactly, right? There can be something. So if there is a toxin in the food, it's going to be detoxified. Detoxification. Nutrients. What are you going to do with the nutrients? It depends. How much are you eating? If you just eat a little bit, the liver will take it and send it to the blood, use it. If it is too much, the liver will put it together and store it. Make sense? It all depends on how much you eat. Most of the time, you eat more than what you need, of course, right? Do we eat exactly what we need? Of course not. There is also extra, always extra. So the liver is going to put them together into bigger pieces. What's coming to the liver? Everything that you were able to absorb And what can you absorb? The building units, amino acid, fatty acid. Are we following? Amino acid, fatty acid. What else? Amino acids, fatty acids, monosaccharides, right? And nucleotides from the nucleic acid, those four. So all of these are simple units. They go to the liver. So the liver will say, okay, you're giving me monosaccharides, glucose. Do you need glucose? Yes, I'll give you some glucose. Do you need all what I got? No. I will put it together and store it. What do we store? What do you call it? When you put the glucose together and store it, what do you call it? Does anybody know? There is a name for it. Extra glucose. You're eating a lot. Are you going to use all of that? Huh? No, it's close to that. Glycogen, yes. Glycogen. You put it together in the form of glycogen and you store it. Glycogen. So metabolism of everything. Carbohydrates, fats, proteins, nucleic acid. Metabolism of all nutrients. You remove the waste products. And storage. What do I store? Anything that's extra. Do you store nutrients? Yes. Extra nutrients. Do you store vitamins, minerals? Yes. Anything that's extra, right? Plus drug inactivation and detoxification. If you are taking a drug or medication, the extras will be broken down. Hematological function, we talked about part of it, which is related to the red blood cells. But then you have phagocytosis. Phagocytes are located in the liver. You make plasma proteins in the liver. Do you remember the plasma proteins? Albumin, globulin, and fibrinogen. Do you remember those? Albumin, globulin, fibrinogen. And I told you we make it in the liver. We did the blood, except for the immunoglobulin. We make plasma proteins. We make the bile in the liver. Remove anything that's not supposed to be there. Hormones, extra hormones, remove it. Extra toxins, remove it. Drug, medication, remove it. Storage of anything. You make bile. And what's the word for bile? The function? Emulsification. Don't forget this. Emulsification. That's why we make the bile. Emulsification of fats. After that, the bile leave the liver and go to the gallbladder to be stored. Do you only store it, store it and concentrate it at the same time? Because when it goes to the gallbladder is trying to store as much as possible, but in order to take good amount, it concentrated. How? Remove the water. Okay? So the gallbladder does not store the bile as is. No, it take it, remove some water, make it more concentrated. When you make it more concentrated, it's more effective and saving you space, right? So what do we do in a gallbladder? Storage and concentration. Storage and concentration. Parts of the gallbladder, fundus, body, and neck. Fundus, body, neck. Neck is where the cystic duct will start. And it will go all the way to the duodenal ampulla, and it's going to open into the major duodenal papilla. There is a sphincter, as I mentioned, that's guarding this common bile duct, hepatopancreatic sphincter. This sphincter control both ducts, pancreatic and hepatic duct. What was the name of the hormone that contract the gallbladder? CCK. CCK. Cholecystokinin. Cholecyst, gallbladder. Cholecyst is the gallbladder. Cholecystokinin. So in cholecysto, and when do we secrete cholecystokinin and secretin? When? Do you secrete it the whole day long, like 24/7? When the stomach is empty, so where is the food now? So when the food is in the duodenum, right? Small intestine start with the duodenum, jejunum, and ileum. Duodenum is C-shaped, and look at the name, mixing bowel, because it receives chyme, it receives pancreatic secretion, it receives bile from the liver. And this is the smallest. Duodenum is just a tiny piece like this, small piece. Jejunum, this is the middle one, and this is where we make most of the chemical digestion. Do we do mechanical digestion? Not anymore. When the food leaves the stomach, it's already paste like, very soft. We're done. So all what you do here is chemical digestion and absorption. So where do we make mechanical digestion? Mouth and stomach. After the stomach, that's it. You're done. It's paste already. No more mechanical. Do you still do chemical digestion? Yes. Where is the main part for absorption? In, intestine, small intestine specifically. This is where you make not just digestion, but main absorption, specifically in the jejunum. Last part is called the ileum. If you compare the duodenum is 25 centimeters, jejunum is 2.5 meters, and look at the ileum, 3.5. So if I ask you what's the shortest and what's the longest of the small intestine, what's the shortest? Duodenum, and what's the longest? Ileum. The last part is the longest. At the end of the ileum, just like anything else, always, any part of the digestive tract, there is a sphincter for entering and sphincter for leaving. What's a sphincter for leaving? And leaving going where? What's after the ileum? Cecum. So what do you call the sphincter? Ileocecal valve or sphincter? Ileocecal valve or sphincter. So not the length, but you have to know what's the longest and shortest. This can be a good question. They don't have to ask you like what's exact length. No, but what's the longest? This is a good question. So here is the duodenum, the blue, the purple is the middle part, jejunum, and look how the ileum looks a lot longer. And then there is the ileocecal valve at the end. Here is the ileocecal valve or ileocecal sphincter. It's the same thing. Valve or sphincter, same thing. Valve or sphincter, same job. One-way movement. In a small intestine, there are circular folds, and these are permanent, does not disappear. Do you remember the roget of the stomach? It disappear, right? Temporarily disappear and then come back. Circular folds of the small intestine, it does not, in the intestine in general, it does not disappear. It's permanent. And we have the villi. Why do we have the villi? Increase surface area for absorption. And there are micro, what's micro? Tiny or small. So villi and microvilli. Because of the presence of these microvilli, this edge looks like brush. It looks like a brush shape. So we call that the brush border because of the presence of the microvilli. Look at these circular folds. This is not going anywhere. Lacteals. Why do we have lacteals? It helps the absorption of fat. Yes. We have intestinal cells. It secretes just like anything else. Mucus secretion plus other secretions. Here are the villi, and on top of it, there are microvilli. What do you call this border? Because of the presence of the microvilli? No, microvilli here. What does it look like? Brush. Brush border. We call it brush border. And here is mucosa, submucosa, muscularis, and serosa at the end. This is the intestinal glands. contain different pieces. What is this green? Lacteal. Lacteal. This is a capillary, arteriolar, venular, and this is a lacteal. We have goblet cells here. What's the goblet cells? This is what secrete the mucus secretion. Do we secrete mucus secretion in the intestine? We secrete it everywhere, everywhere in the digestive tract. Do we secrete mucus secretion in the duodenum? It's everywhere. It goes without saying. What are the secretions of the intestine? You secrete buffer, just like the bicarb. Is the food there still acidic? A little bit. It's just came to the duodenum from the stomach. It's acidic, isn't it? You add bicarb. So it's not acidic anymore? Not yet. Still acidic. So you add more. Plus the enzymes. Enzymes come from the brush border that I just mentioned, and that's why I told you it looks like a brush, because the enzymes come from the brush border. And you know why it's called brush border. What are the enzymes that we secrete here? Enteropeptidase. Enteropeptidase. And what is this enzyme? Why it's important? Because this is the one that activates trypsinogen. What activated trypsinogen in the stomach? Hydrochloric acid. And what activated trypsinogen? Enteropeptidase. Remember this name. What activates pepsinogen? Hydrochloric acid in the stomach. What activates trypsinogen? Enteropeptidase in the brush border. Motility, it's controlled by the myenteric plus sympathetic and parasympathetic. We mentioned the sympathetic and parasympathetic. Do you know where is the myenteric plexus located? Where is the myenteric plexus? What's myenteric means? Myenteric. I mentioned it in the lab. Huh? Muscles, yes. So where is the myenteric plexus? In the muscles. So if you see something white in these models, white, something white, swelling white in the muscles, myenteric plexus. This is a myenteric plexus. It's a nerve plexus. Reflexes here, there is a reflex between the stomach and the intestine, gastroenteric reflex. And there is another one that's called gastroiliac. But the food doesn't leave the stomach, go to the ileum. It go to the duodenum. Why gastroiliac? Yes. Do you guys remember the short and long reflex or not? I mentioned that. If the food is leaving the stomach and go to the duodenum right beside it, is that a short or long? Short. How about when the food leaves the stomach and you send the signal to the ileum, to the end of the ileum, ileocecal valve? This is a long reflex, isn't it? And what's your goal? Why are you relaxing or opening the ileocecal valve? To empty the way for the newly coming foods, right? Food leave the stomach, go to the duodenum. What should I do now? The food is coming. Empty the space, right? Empty. Leave the ileum. Allow the food to leave and go to the next component. And here are the reflexes: gastroenteric and gastroiliac reflex. And we can stop here. 170.